The first thing that we're going to be talking about is ionizing energy, which is the energy needed to completely remove one electron from an atom. As you can see from the picture that I have right here, the ionization energy increases as you get closer to helium. The next thing is electronegativity, that measures the attraction between a nucleus and the shared electrons in a bond. It generally decreases as you go down the periodic table because the valence electrons are further from the nucleus as atoms grow larger, as you can see from the picture that I have. The atomic radius is a measure of the size of its atoms, the distance from the nucleus to the boundary of the surrounding cloud of electrons. It decreases as you go from left to right because of the greater amount of protons. The alkali metals are found in the group 1A, which you can see that is highlighted, circled or squared or boxed. And they are very reactive and have one electron in their outer shell. Alkaline earth metals are found in group 2A and all share similar properties. They are also very soluble when combined with other elements. Halogens, or however you say that word, are found in group 7A. They have very high electronegativities and have 7 valence electrons. The noble gases are found in group 8A. They are also known as the neon family. They are the most stable since they have the maximum number of valence electrons in their outer shell. Transition metals are found in the center of the periodic table, and they are known to have multiple oxidation numbers. Okay, so this is the part that most people are going to fall asleep if they haven't already. But now I'm going to be talking about the history of the periodic table. The modern periodic table organizes the elements in several ways: electron configuration, reactivity, electronegativity, etc. This is a good method to organize elements that are already known and to predict the existence of other elements. In the Middle Ages, alchemy was sought to make gold and silver from lead. But as we all know, that didn't work out unless you are Edward Elric. Fast forward to the more modern view of the periodic table, where scientists began to notice similarities and patterns among the known elements. The first person we're going to talk about is Dmitri Mendeleev. Great name, by the way. It reminds me of that guy from Anastasia. Anyway, this is back in 1869 when he stated that the elements were very periodically according to their atom masses. He also separated his elements and left spaces on his table for other elements to be added. He even predicted the properties of some of these elements. Noble gases were added in 1894 through 1901. Then Moseley's atomic numbers were added in 1914. A year before, in 1913, the Bohr atomic and electronic structure were presented to the public. And finally, in 1939, to this day, the discovery of synthetic elements began. Now, before I actually end this video, the last thing I want to talk about is the physical and chemical properties. So now you might be asking, what are physical properties? Well, these properties are the ones that can be observed without changing the substance to another substance. For example, color, freezing point, boiling point, melting, density, and smell. The next question, what are chemical properties? Well, these are the properties that can be observed when the substance changes to another. For example, burning, rusting, heating, and even exploding. Thank you all for watching through this whole video. I hope I didn't bore you. Now, there are 5 questions I need you to answer in the comments below. Even if you don't know the answers to this, please don't cheat and don't go back to wherever the answer is in this video.